So today I really like to talk about the secure C++ principles from the automotive industry. And yeah, and I'm Sabariesh. For anyone who joined a little bit before, would have heard about me talking about myself a little bit. So right now I'm working at Ambition, which is a spin-off company from Mercedes-Benz R&D. So where we are developing infotainment platform and applications for self-driving cars and ADAS systems. So we do a lot of develop software for automated driving systems at various levels. And before I joined Mercedes-Benz, I studied in India, in Chennai, in Anna University, and then I moved here to Germany to do my master's in communications. And after that, I was working in several industries. For example, previously I worked at Philips R&D, where we did digital photon counting. Like for example, it's used in MRI scans for detecting cancer and other illness. And then I've worked at like another company called Omicron Electronics, where we did high voltage partial discharge measurement systems. And now I'm at Mercedes-Benz developing infotainment platform, in specific what we call as dynamic content, where it's similar to the app store in your phone, like extending the platform itself, updating the applications, updating the software, so over-the-air updates and everything related to automotive software. So let's quickly go into what's automotive security, right? Like, you know that the cars are increasingly becoming digital. So they are more connected to the outside world and talking between each other. So this is a potential reason compared to the traditional cars that there is an exploit that could be vulnerable and could be exploited by the hackers and could be controlled remotely, like you can see from the news snippets that I took from internet, like hackers taking over a Jeep that is running on the highway. And there is a huge Tesla hack that happened a few years ago, and hackers also controlling the cameras inside your car. If you know that there are a ton of cameras inside the car now. So if you compare this, so it's our responsibility as a software industry, right? So we should be conscious of it, try to prevent it, and we have a shared responsibility towards it. If this happens in another industry, like construction, for example, if they are building you a house and they have a secret trapdoor, and then they provide this key to the burglars, right? Like this is exactly how we are dealing with this. So we are building autos and we have a secret vulnerabilities which are known to hackers, even not to the software developers themselves. And then we are providing key to these hackers to exploit these vulnerabilities and take over the cars. So we should be more conscious of this, what kind of principles we use when we develop software, both in sense like architecturally and also some of the software features and the C++ features themselves. Yeah, now another interesting thing that I was attending a training for security, and there was this question asked, like, is there a difference between safety versus security? At least in some of the Indian languages, and in German, for example, there is no differentiation between the word safety and security. In German, it's just Sicherheit, which means both could be safety or security. Maybe one of my colleague who knows Hebrew told me that in their language that they do differentiate between safety and security. Maybe if some of your guys also know in your languages if there is a difference between these two words, it'd be interesting, right? Like, but if you consider what is safety, it's if it happens something unintentionally, right? Like if the airbags fail to open up when the accidents happen, or the seat belt loses their grip and opens up when there is an accident. These are safety issues. This is what the traditional auto industries deal with. For example, Volvo or Mercedes, they are good with dealing with these. But the security is another aspect of it. Like it's trying to protect the intentional incidents. Because, like I said, the autos are becoming increasingly digital, and this opens up a way lot of security issues. So we should be conscious also about this differentiation, and that's why I know that the auto industry is spending a ton of money now with respect to security. Yeah, now let's go into the detail, but I'm going to just give an overview here about what we call as like threat versus security features, the strike principle. I'm not going to go detail into every one of them, but just to give you an overview, like if there is a threat of spoofing, how can you overcome that through authenticity? Through if there is a tampering, then you should enable a security feature that creates integrity in the system. And yeah, so various other strike principles, right? Like if there is an elevation of privilege, for example, in Linux systems, you could be various users, and then if the system hackers take over some of the components, they could increase their privilege, increase their trusted execution environment. So how could we prevent that? Through various authorization modes. And one of the ways that we can visualize or imagine about the threat, right, like this kind of threats, is through threat modeling. So threat modeling is a structured approach of identifying and prioritizing the potential threats to a system and determining the value that the potential mitigations would have in reducing or neutralizing those threats. Because if there is a threat, which is a risk, then you have some sort of mitigation plan for them. And threat modeling approach is like you have the model of the application, and then you do threat analysis, and then you prioritize which threats are more damaging the other ones. That's why you have like in this threat terminologies, modeling terminologies, we use like threat agent who acts on this threat and what's the impact of it, what is the likelihood of this happening, and what are the controls mechanisms that we have to protect against such a threat, what's the prevention mechanisms, how we can mitigate it if the risk increases, how, and we can visualize this through the data flow diagram and create trust boundaries within the software components. We use one of the threat modeling open source tool called Patum, um, which is a forked version of it. So we have a modification to it, but yeah, take a look at this open source project. It's very interesting. So just to give you an example how this kind of threat model would look like, right? Like, so at the beginning, I mentioned like we work with this kind of dynamic content in the infotainment platform, which means bringing in external application inside the car, which is a new aspect to the car because after Tesla disrupted the whole industry, now everyone wants to see new contents in their car every 1 month or 2 months, something like this. So how can we bring in such an application? It's not possible for every OEM or auto companies to work on these feature sets, bring in the car back to the workshop and upgrade the software. So that's why you have over-the-air update. And also there are a lot of provisions to update the software itself in smaller portions instead of the whole applications. Here, for example, you have a traditional app store and you have a UI and the app store running in the UI, and then there is a user who wants to install an application, clicks install app in the UI, and then there you have like an installer service which installs it, and there is a container service because you want to sandbox or yeah, your these external applications, right? You don't want to run them on the same level as your system components or the ones which you trust. So that's why you want to isolate them and run them in a container environment. So you have this container services which starts these applications, and then the installer service would try to verify whether the applications that we are installing has some sort of signatures on them that we have performed on the backend. And this is the application, right? Like, so we want to visualize this. So this is where the tool helps in modeling this kind of application, and then it becomes visible what the threats are here. For example, the containers, the applications inside the containers could try to increase their privileges once they are started running in the container. Or they could try to spoof themselves as another application and try to get some details of the users for themselves. So these are the kind of threats that we could face, and how we could mitigate against them is potentially then the threat modeling, outcome of the threat modeling. And then you can come up with various mitigation plans and how you can disable these applications, how to prevent them using most of the resources in the car and stuff like this. Yeah, now let's see. So like when I said like the car is becoming digital, you can say it is becoming itself as like a distributed computer system, right? Like it's now like a complex distributed systems, which has millions of lines of codes executing on them. And you can see different type of network protocols running on them. For example, you have like this kind of telematic systems, which connects to the Wi-Fi, Bluetooth, and outside world through internet. And there you have like various short range channels, and there is long range wireless networks, and then there is a CAN networks, which allows the communication inside the car itself. So it's a really complex system, and this kind of opens up also potential threats. And you can see that has like various digital I/O channels now, and this could be for like you can have like a PC with the USB control, and you can have an access to these electronic systems inside the car. You can potentially connect to that interface to hack into it, or you can use like short range wireless access to connect to the auto and morph yourself as like an access point, and could get more details about the car, or even open the car by yourself even without a key. We will see some of the case studies that I can show you at a later point of the presentation. And now quickly, like we have a separate coding standard in automotive industries. MISRA C and C++ are the traditional coding standard, which was available for automotive industry for a long time. So that's why you see C++ 03 being supported, and there is no additional standard from MISRA in long time. So this is being changed. MISRA is now, which is a conglomerate of all the auto industries. They are coming up with new standards for the latest C++ standards. And that's why you see that MISRA C++ doesn't have any memory management vulnerabilities, or not being mentioned in them, or because they concentrate more on the safety side of the auto than the security side of it. And the memory management vulnerabilities are some of which are exploited in security features. And then if you see, then we have also AutoSAR C++ 14 standard, and this allows dynamic memory use, but with some restrictions. They do restrict like a naked pointers, like new that's allocated through new and delete. Instead, you should use like RAI principle, right? Like resource acquisition is initialization principles, and you shouldn't use any malloc or calloc yourself, or there is no pre-allocation of memory. So AutoSAR has much wider range of as a standard, it provides wider range of features. Now let's go through the C++ vulnerabilities. Yeah, so this is a neat little graph, that is a chart that I found. The graph really shows, right? Like if you see, it is a study that was done in 2017, which comprised of memory vulnerabilities between 2000 and 2016. It's slightly outdated, but it's still quite relevant in showing how trends changed over the years. If you can see, then now in the blue, the heap related problems have grown to be like most significant vulnerability type, followed by pointer and integer problems, which you would expect, and the stack-based overflow dominance, right? Like in initial days, because the stack is the easiest exploit, but now it has reduced. And but the other hand, if you look the format string related problems, it used to be a significant source of memory errors. Now they have all but completely disappeared. And many of these changes in the trend you see are mainly because of the improvements in the compiler tool chain, as well as in the language standard itself. So let's see what are some of the memory management vulnerabilities, right? Like I mentioned, there is buffer overflow problem, there is pointer manipulation, integer handling, format string issues. Let's see some of them. And if you think that the memory-related issues are not anymore because C++ uses now smart pointers and you don't have to handle the memories yourself. There was this study from Microsoft, which shows that 70% of all security bugs are memory safety issues. This is also slightly outdated, but it's still relevant. So first, let's see the memory vulnerability, buffer overflow. So the buffer overflow could happen either in the stack or in the heap. And buffers are nothing but like section of memory, right? That hold data referred through various pointers. Any mistake in using these pointers can be exploited in several ways. It could be over-reading buffers or under-read buffer, which could lead to confidentiality issues because you could have some memories where you have stored your password or some other, like what kind of cryptic hashing you are using or something. Or some, it could create an integrity issue, or it could even do a memory corruption and crash the whole application, which would lead to like denial of service attacks. But there are like other languages, for example, Java or C#, which are usually safe because they don't go into this kind of memory by themselves like C++ does. But it could also become unsafe because there are some interfaces provided by C# and Java, which if used could be potentially damaging. So so what kind of this buffer overflow, what does it does is like, so let's see this example, right? Like, I wanted to show you guys some sort of demo, but then when I tried to do it myself, it took me easily 30 minutes to go through each, compile the application, start the ARM QEMU, and then start the debugger, go through the memories, and then show you this example. So instead of that, I would just quickly show you some example programs and how does it looks in the memory, how it could be exploited. So let's see this example. So you have like an authentication function which have these memory allocated, and in the stack you can see that the you have, this is the verify password section of the memory, and then this is the authentication where you have these variables which are allocated, right? So now what could cause this buffer overflow problem is, for example, here you can see that there is a strict memory allocated of this character variable buff of 8. And now if you read this through the gets into the buff, and if the entered value, for example, the password in this case, if it's larger than this could potentially cause buffer overflow. So you're not verifying what's the user input is, and this could lead to the buffer being overflowed into the next stack frame, and you override some of the values that is in the memory. And how this could be exploited, if you think about it, in this case, you could have potentially like a malicious attack who is trying to insert their own shell code in this case. And in this shell code, they have like instructions how to remotely access the system. And you insert the shell code through this kind of buffer overflow into your memory, and then you start this shell code, and now you have access to the system. So this is one of the examples of this kind of buffer overflow on Stack. Like I mentioned in the chart, this is becoming less because of the various protection mechanisms that is used by the language itself, and also some of the compiler features. And if you look at the buffer overflow on the heap, so heap is like a dynamically allocated memory, right? There is no return address on the heap. But if there may be some pointer in the heap as well, because you can have like a function pointers or like a virtual function table which are dynamically created at runtime, or some heap headers. And this could be also, like I mentioned before, like when you allocate memory, and you can potentially overrun this memory and insert your own shell code or like or some different return address that leads to a different region of the program. This could also potentially be damaging to the system. And we can see some case study or real life examples this happened, right? So this is an example of buffer overflow that happened in the Tesla Model S. As you can see, this is not that old. It's from 2020. If you go to this source page, you can really see how the hackers exploited this error in the Wi-Fi module of the car, and then they were able to start their own shellcode inside it. So in this example, if you can see, the car was connected to like some sort of unsecure access point. And then the vulnerability exists in the process of copying the data from the response packet here in the host command, ADTS request. And the length of the copy is calculated by subtracting the 4 bytes of the length of the action header from the length of the action frame. And what happened was, like, what if the action frame only contains a header and the length of the header is only 3 bytes, right? This would lead to like a typical buffer overflow. And this would lead to then the length becoming the highest possible, right? Like, and this would cause the memory to be corrupted. And also you can potentially expose some of the sensitive data that is stored in the memory. So after triggering this vulnerability in the chip, the whole RAM region then is corrupted, and the firmware cannot work anymore. And there is the interesting thing about this is this exploit has also shown us another vulnerability in the kernel stack of the chip. And you can see that here in this second example. So you can see that the VLAN prepare CMD command will call the returns the value here, and here in this the value returned from here is not being checked or validated. This led to a buffer overflow in this case. So if you think about the whole exploit process, how these guys did this is, like, for example, the attacker sends like some sort of deauth frames to all the access points that's nearby, so they don't know at first what are the various access points and what are the clients that are connected to it. And so when the auto, like in this case, the Tesla reconnects to this access point, the attacker gets the MAC address of the Tesla because now it's one of the access points. And then it sprays the fake pointer that triggers the vulnerability in the firmware that we saw first, and thereby directly sending the corrupt action frame. And then is the memory copy is executed, and then the interrupt occurs. And then in this stage 1, the shell code that is inserted then sends like events to the driver or to the auto itself. And then in the stage 2 of the buffer overflow in the stack, which was not previously expected from the hackers themselves. It allowed them then to exploit this through another shell code. And this allowed them to take over the whole car, because now they are in control and they can send various commands or can crash the car, this Wi-Fi system at any time. And another example, probably you might all be knowing about, is this kind of heartbleed. Here, this was, I think a lot of us use OpenCA SSL library for some sort of authentication mechanisms. So here, this was the first vulnerability that got really large-scale recognition outside of the security community itself, because without us knowing, we are using this library in a lot of our devices, right? So potentially, it's more threatening than just restricted to the auto industry in this case. So in this case, the client comes up with some sort of random binary string, the payload. The client sends the message to the server with the payload. The server then sends back the response. So this is some sort of authentication mechanism, right? Like where you just ping to the system and then it pings you back. So then the payload in this case is just copied back, and then the server responds with the same payload. But the server did not verify the provided payload length. So what would this cause is, like, for example, the payload length is not considered, and here they are using their own malloc, like OpenSSL_malloc function. So this means that we don't know what happens behind. And then the payload, so we allocate the buffer using the length of the payload, but what if the payload itself is smaller in size? So this led to this memcopy copying, potentially leading to buffer overflow and reading the memory that should not be accessed by the client. So this leaked memory that could potentially contain like TLS keys and also some plain text user passwords. If you look at these libraries, you can see that some of them actually store these user passwords in plain text, and even some credit card details and stuff like this. So this was one of the really famous case study, and I would highly recommend you to go through this this link where it explains about what the case study is about. So let's go into now another memory vulnerability, that is pointer manipulation. So in this case, the code pointers also could be targeted, right? For example, a jump table, for example. So this jump table is nothing but a memory containing function addresses, right? The table is stored in the executable and looked into the memory. It's created by the compiler and used at the linking time. And the code jumps to the address stored in the index within the table. So call tables can also be created programmed. For example, global offset table and the virtual function table. I think we know about the virtual function table. It's one of the polymorphic virtual functions that it's created dynamically, where you can look up which virtual function should be called based on the polymorphic classes. And smashing this virtual function tables are a classic example of how you can hack the heap overflow memory. So here, like for example,
again, someone had interrupted the screen sharing.
Okay, let me continue now. So the virtual function tables in C++ are the prime target, right? Like, or these are not specified in the standard, so the implementation is compiler specific.
Sorry.
Sabariesh, you will have to share your screen again, please.
Yeah.
Oh, really? You're not able to see the screen?
They just got turned on.
My mistake.
Yeah, sorry, I think by mistake I tried to share the screen. I think it shared. So I don't know. Sorry.
Okay. Okay. No problem. So are you able to see it now? Okay. Thank you. Okay. Yeah. So smashing this virtual function table then could allow you, the hackers could potentially insert their own shellcode and execute their function instead of these virtual functions, right? So this is also potentially caused by the heap overflow that we saw before. And it could allow these hackers to insert their malicious pointers and return to their memory addresses instead of the intended mechanism. Yeah, so how can we protect against this, right? Like, so I'm going to go through some of this memory management hardening techniques. So we just saw how can we protect this kind of stack smashing, right? Like buffer overflow on stack potentially could be damaging. We saw some case studies which allowed the hackers to exploit this. One of the technique is like using the Stack Canary, and this is provided by the language or the compiler itself. Its implementation it generates some sort of random value, store it somewhere safe, typically thread local storage, and it verifies the values intact before returning from the function. So you have like this between the local variables that is assigned in this state frame and then the return address. So if there is some sort of buffer overflow and this state canary, if it's not verified properly or if the value is not present anymore, then it could just kill this whole stack and then restart the application. So this is one way of protecting this kind of stack smashing. And another way of this kind of memory hardening could be done through like address sanitizers. So the address sanitizers are like this compile time tool provided by Google, which were they originally designed for Clang, but also ported to now. I think it's available with GCC. It has a better performance compared to like other memory debugging tools like Valgrind, but still it's very costly to use. It's sometimes even consumes like 70% of the CPU time. And if it finds a potential memory corruption problem at runtimes, it terminates the program and dumps the debug information about where and how the invalid operation took place. So which could be useful to fix this kind of errors. So this is something which we also use internally to run against our program in the CI/CD pipeline, and the bugs are created against them frequently. Yeah. So now let's go another problem. It's integer handling problem. This is a really classic example, right? Like from C standard that you know that the integer types are one of the primary types, and they are implicitly converted. And here you have like some sort of rank, like the character is smaller than short integer, though it is based on the platform, the size of each of these types, but the character is smaller than the short integer, and then which is shorter than integer, long integer, and long integers. And then there is this implicit conversion in each of in this integer type would potentially be also could be like a tricky bug that could be difficult to resolve. So for example, if you look at in this example here, then the user data is read into one of the variables, and then the variable is then incremented, which could lead to like integer overflow issues. And so one of the thing could be like you could avoid this kind of implicit conversions from one type to another, or within the same type, even if you're considering integer as a single type, as much as possible. And it should not force this implicit promotion. For example, here, this is you have a short with A and B and an unsigned integer C. And this would force this kind of implicit conversion, which could lead to C being overflowed if the A and B are at their max value already. And you can also see that the casting don't perform promotion or cast as a different essential types. If you could not see, these are circled with red boxes, which means you should not do them. So here there is like unintended promotion from one type to another. This could also lead to like some security implications. So for example, it could cause some logic errors that compromise the security in other ways. Like if there is an order item, it's an online order system and someone orders a very high value of items, and then the price of these items could potentially overflow to a small value, right? Like because it overflowed and then it could be assigned a smaller value to it. And when you are transferring, if you don't do it without some sort of input validation, a -$1 US, this will cause the integer again to overflow if it's an signed integer, and then it would look like a 4 billion US dollar. So in general, any kind of such calculation or mathematical operation may be forced to give incorrect results by an integer overflow, or sometimes even underflow, in which we saw the price could reduce, right? So technically, only signed integer overflow is undefined behavior in C. An unsigned overflow just causes a wraparound. From a security perspective, however, these two situations are equally bad, whether it's an underflow or an overflow of the integers. So what are some of the best practices you can see? One of the best ways is to do some sort of checks or input validation before assigning the value itself. For example, instead of just assigning or converting implicitly or explicitly here to the product count to the short count, you can check whether it is already lesser than the maximum value so that you can assign that. Or you can even perform a precondition test before assigning a variable to it. Here in this case, like performing some arithmetic operation, right? Like instead of just adding them these two values and returning, you can see whether the B is potentially could hold these two values and return this. And by definition, since B cannot take a larger value than the possible largest possible integer, then the second method is guaranteed never to overflow in this case if you use some sort of precondition test. And in the post-condition test, if you could check before returning the value whether this has caused some sort of overflow or not. Yeah, so some of the tool usage of tools that could prevent this is like using some of these GCC flags in your tool chain, whatever you are using in CMake or Make, or any of the other modern build systems that you're using. Yeah, so a general practice is to use unsigned type for variables that are not expected to take negative values. For example, buffer length. This can take advantage of the integer promotion rule to potentially prevent signed-unsigned confusion vulnerabilities. For instance, if you use size underscore t type in all such situation, it will always be okay, because size underscore t is unsigned type. Yeah, so let's go into the next. So we saw that format string issues have become less and less frequent these days, but it could also potentially leak some information to the hackers, like we see in the next slide. So if you look at the printf and sprintf, they are like a variadic functions, right? Like, so the first parameter is a format string, defines how the other parameters are used. So more importantly, it also tells printf how many parameters there will be. And printf will perceive its state frame differently depending on the format string. On the design level, the main issue is like the implicit trust for this format string, right? So using incorrect specifier is always a problem. And if you do some, if you don't do the specifier, if you don't do some checks, then it could lead to info leak and possibly also denial of service attack, even if the format string is hard-coded. And this example that I found from Twitter, like you can see that one of the users using an access point or like the Bluetooth named their devices as like one of the string formats. And this allowed the attackers to learn the memory address, defeating the ASLR, like this address randomization space layout. So can also dereference heap pointer with %s to learn passwords and other valuable data. So this could also potentially be exploitable. Here you can see this is from Audi A4 and this is from BMW, I guess, and these are from 2018. And you can see here this kind of shows you what the device address is in this case, and also here. Yeah, so another security vulnerability that you can consider is also exception handling. So an application should be always prepared to encounter such exceptional situations, right? By the way, you can see some of these in the CWE, where it's like an like sort of an open source database where you can see potential exploits being compiled here. This application should the application should handle such exceptions and return back to the stable state. That's what you expect the system to do. So, and then the exceptions are really for exceptional situations like out of disk space, or if you fail to open a file, or losing internet connection. And if you look at this example, again, it has a boundary with red color, so it's potentially dangerous. Here, if you see in this example, the get host by address, right? Like, so this could return some sort of null value. And if the HP which costs this value is not checked, or like it doesn't throw anything, and then you perform some sort of string copy on it, it might cause buffer overflow. So if an attacker provides an address that appears to be well formed, but the address does not resolve to a host name, then this call to get has host by address will return null. And since it doesn't check for this return value, null pointer dereferencing could then occur in the call to the string copy, which would lead to like some sort of buffer overflow. And so you have some sort of exception handling, but it could be also like an improperly handled in some cases, which could be also exploited by the hackers or the malicious person. An empty, for example, in this case, if you have a try and catch block and you have an empty catch block for like an for whatever reason, or you want to implement it later, you don't know how it's specified, this could potentially be dangerous because you don't know what will happen in the future or who's going to implement it. I would take a look at this vulnerability here, exploit that is mentioned here, this empty exception block, what it could cause. And the use of exception itself, whether to use exception or error codes is still debated, right? Like different projects decide on various ways of implementing it. But from a security perspective, exceptions provides more room for error and thus vulnerabilities. But a well-implemented system will not necessarily suffer for using exceptions. And the proper way to handle exceptions should be consistent strategy applied throughout the entire program. So whether it's handle every exception on the spot, or you want to rethrow that and let the outermost layer to handle it. Even just doing something innocuous, such as logging the exception and rethrowing it may result in duplicate log entries, and depending on the other exception handler's implementation. And so what are some of the best practices, right? Like So you here don't throw across execution boundaries. For example, you're using some external libraries, which is using a different ABI, application binary interface, if you don't know what that is. So just use error codes instead. Because with respect to the execution boundaries, the main danger is throwing an exception to a code that is not fully interoperable with the throwing code. In a typical case, this can result in exception not being caught, and std terminate could be invoked. And this is clearly a denial of service. And also handle the exceptions thrown before main. For example, in the initializers and constructors must not throw uncaught exceptions. So that's why you could potentially use no except keyword for such a constructor. And if you are using some sort of global variable like static, which is created before main, this could also throw, but it cannot be caught, and it will cause like an abnormal termination. So this is a red case, and then the good case is then use something like a constructor to construct such an object and handle the exceptions inside the constructor. Another best practice here, if you could see, then in this kind of you have like an exception class, and you use a string to throw around the messages inside that exception class. And this string, when you're constructing, could, or copy constructor of this, could also throw. And that's why it's better to use something that doesn't throw. For example, in this case, runtime error type instead of using a string. So because when throwing an exception, a new copy of the exception object will be initialized through its copy constructor. So that's why you should be a little bit more careful in using such types. And then an overboard catch can also lead to issues like the object will be initialized through std exception instead of yes. This is called, then it would lead to some sort of object slicing, because it could lead to some data loss. That's why it's in the catch exceptions, always use L value references and always catch more specific or derived exceptions first. And another interesting, or like it doesn't just also doesn't imply to to the whole software industry, right? Like this kind of input validation. So you have like a requirement which would look like this, or the specification, but you are implementing in a different, or like you have some sort of rigid boundaries around these specification. And this kind of rigid boundaries could lead to some sort of potential hack. And these are some like you can see that you assume certain things in the software that the user will send only the positive cases, right? Like, for example, in syntactically, you see that some sort of invalid structure could be passed, for example, in the XML or JSON cases. And if you're not doing some input validation of these schemas like XML and JSON, this could lead to some sort of unexpected behaviors from your software. And semantically also, like inappropriate values in the given context. And input validation is probably the single most important thing a developer can do to protect against vulnerabilities, right? After all, the attacker has got the malicious input into the system at some point. But creating 100% bulletproof input validation is really difficult, especially if the structure of the input is complex. It would basically require a formal proof that validated data cannot cause the system to misbehave in any way. However, in practice, restricting the possible inputs can significantly reduce the attack surface and make the job of the attacker much more difficult. Well-implemented input validation can also eliminate several vulnerability types itself. So how can you handle this, right? Like there are some best practice. Like you can blacklist on enlist and define the bad cases, but this is a little dangerous because you can never know if the list is complete. And in this case, the else case could be very permissive and accept a lot of different kind of inputs. And then if you go for whitelist, in this case, and define the good cases. The else case in this case could be really restrictive or reject a lot of things, which is good. But it is also a weakness if the list that you are using to validate is too broad and permissive. If it is too strict, that's usually just a functional program that you're doing. Yeah. And if you want to do some sort of type validation and also like a range and constraint validation and this structure check, for example, this kind of schemas, right? Like about the XML and JSON again. You want to check whether they are properly fully formed instead of just reading them through and causing some unexpected behavior. Yeah, now let's look at some of the exploits in doing files and streams. So this could happen when the application relies on path name for access control instead of using some file system services. So that's what we all do, right? Like we try to get the path, absolute path. For in this case, for example, you want to read this dictionary file and get all the environment variables from there. And what if this dictionary file variable is set in the platform itself to some environment variable, for example, etc password, pass twd, right? Like this could, because this file stores various user information, it's a plain text file, so this could lead you to read this file itself and expose this information. And in this second example, if you do some sort of relative path traversal, for example, you have this path is hard-coded and you ask the user input for some file name, and then you copy this. What if then there are some escape characters, right? Like if the user is trying to exploit this and trying to go back in the file system and trying to access the root file system. So, and there is another really nice example from the GCAB library, which is Microsoft Cabinet Archive. In this vulnerability, here, if you see the zip, though it's used frequently, refer to this vulnerability, it is actually a general problem, right? Like that applies to any archiver that supports storing the file path in the archive. So in this code, there is no validation of the entry's file name. So an entry could contain like, so you have like depth of folders in your archive, and you're not validating against this folder names, and then you're trying to store them in your local file system. Then it could contain like potential backward slashes that could allow you to go back in the directory, and this would cause some exploitation types, like you can store these files in the root file system and could allow the execution of them. So the solution for this could be like canonize and validate the path names before writing into the file system. That you will see that in some of the best practices here. So for example, here, when you're using the open, try to use this flag, like no flow, so that the symlink, it doesn't allow symlinks when opening the files. Or use lstat and fstat after you open it and compare it with these attributes of the stack structure written by them to see if the file is the same. And for hard links, distinguishing is impossible, but one can still check if a file has more than one hard link with lstat. And another general files best practices would be first of all, don't rely on the path checks for authorization. All file system apply access control and use that. And canonicalization of these functions could be also really useful. And most importantly, use a whitelist instead of blacklist, because this could be easily circumvented. Because just think about all possible encoding types, right, that you can blacklist. You should take into account in this case, like Unicode, URL encoding, etc. Yeah, so we are almost reaching the end of it. So like, so in this case of initialization and cleanup, so non-trivially constructor types object need to have explicit constructors and destructors. And on the, I think this is a general principle which most of you might also know, like do not invoke virtual functions from constructors or destructors. because that would lead to like an undefined behavior. And do not delete polymorphic objects without a virtual destructor in the base class. This could result to like denial of service attack and could also lead to resource leaks, because think about, you have a derived object and then you're deleting it without a virtual destructor. That could lead to like a memory leak. And also think about like this canonical order of initializers. It's specified already in the C++ standard. In the exception example, like at the bottom here, try to use the value of the name in the catch block. This will cause an undefined behavior, definitely. And by the way, there is this WR W reorder GCC flag that gives you general warnings about these. Yeah, so maybe some more additional mentions since we reached the end of it, like for example, denial of service attacks, basically any attacks that targets the availability of the systems and trying to not make it not available for the legitimate users. This could be a lot of different forms like flooding and network-based and distributed among multiple attackers' machines, and resource exhaustion and vulnerability exploitation. And there is another one, regular expression denial of service, where because most of the regex engines, regular expression engines, are implemented using a non-deterministic finite automation, right? They must check every possible state. So this can be exploited with evil regex, which could cause like some sort of denial of service because you're blocking the whole process here. And hash table collision is another example, because the hash functions used in the hash tables aren't collision resistant, unlike cryptographic hashes. And the attackers knows this algorithms used by the program, and then it's relatively easy for the attacker in this case, because they can use this, find some inputs that generate the same hash code and give the same user this input and make this collision more often, which could also lead to some sort of denial of service attack. And always be careful of unreleased sources. Yeah. So that would be the end of my presentation. Thank you. It is a little bit longer, and it's a really complex topic. And we can handle it more by using some examples, which I could probably show in future presentations. But yeah, thank you. If you have any questions, I'd be happy to answer.
I think we have some questions in chat section.
Ah, okay, sorry about that.
So if you want, I can help you to read it out if you are not able to switch between the screen.
Sure, because some of them are more like comments instead of questions, I guess, right?
So one question
I guess we can ask the questions directly.
Yes,
Yeah.
you can unmute
Is the bear?
whoever have posted the question there. So Shashank, you can start. I think you have posted the first question.
Oh, so my question was like about these overflow attacks. The main idea is that one application or one process which is running, it executes code and starts another process. So if we have sandboxing systems which actually run it inside a sandbox, run the code inside a sandbox, can these overflow attacks be prevented?
I mean, you could still exploit this within from the sandbox, right? But think about the system architecture or the complexity of such a sandbox environment. You have various system services which are running inside these sandboxes, and how would they communicate between each other if they are sandboxed? And this increases the complexity of the system architecture. So this is one of the reasons this is kind of avoided, that you don't see like each of the system services being sandboxed in their own environment.
Okay. Thank you.
Next question we had from Honey. So could you unmute and ask the question?
Hi. I have a few questions actually, so I can take the next slot if somebody needs to question. Okay, thank you.
Hello.
Hi.
Yeah. So I just have one question regarding the how but if everything we start keep checking, or are there some other tools that we can use or something, because how the latency goes with this. So if there's some application which is latency critical, I cannot like put branches before something and then after something. So is there any other things that is by using the new features rather than using the raw things? So is there anything that I can avoid these things?
Yeah, like if you have such latency sensitive application, right? Like, then probably you should run them in like some sort of trusted execution environment, you know, so that they are not. It's running natively. At the same time, you are running it in like some sort of like trusted environment where the other components potentially could not communicate with them without some validation.
Okay, so you mean we need to run it so disconnected from the outer world, so no one other can access the system that time.
For example, yeah.
Okay. Are there any other approaches like using the raw array, like normal raw old arrays or something, by using the new things like STD array or something? Will it solve the purpose or no?
I wouldn't call STD array as a new feature, but I mean, any kind of such features could be also exploited, right? Like at the end, it allocates memory in the stack, and
okay. One question. So it's still, so I think Tushar replied that and gave some links. So I still I never did it. So I think it like a habitual scenario. So or some other time, can someone take the session on this, on showing live that how to approach, how can someone exploit this, or giving a live demo, or how I can learn that this like these code can be injected and then these things might happen or something, by a simple example, by running a simple shell command, by putting some, or is it too difficult that we cannot do it, only hackers or the dedicated teams do it?
Actually, I have an example that I did a presentation within the team, but this is I don't want to show it here because it took like 30 to 40 minutes just to show Stack Overflow.
Yeah, that's understood. So that's what. Can there be any other session for this, so that we like personally, I never I cannot imagine it how it can be done. So that's why I'm asking this question. So
yeah,
otherwise other guys can do and other teams can do, or other hackers can do it, but I never see it in live in myself. So that's why I was thinking that I asked that question.
Okay. Yeah, maybe in another session, definitely.
Do a small working example in like 30 minutes.
Yeah, a simple separate class or separate session for this.
I mean, the simpler itself, you have to go inside the memory and go inside the GDebugger and go through the memory, find this right memory, and then create the shell code, and then replace this memory values with your own shell code, and then so it would take a little bit more time, and it's definitely not simple.
Yeah, probably not 30 minutes, but I sent a YouTube channel live overflow.
Yes, you used.
This
Yeah,
guy
I
has
that channel.
The guy has a playlist for buffer overflow, and in that playlist he's doing all that sort of stuff. So you can go check that out.
Okay.
Yeah, I mean, without looking at it, I can say it's definitely not simple. I mean, if it's simple, everyone try to hack every system possible. So.
It's not simple. It's just it's difficult. Like once you find,
because we don't know the other's address space or something. So
yeah.
Okay, cool.
So Sabariesh, maybe you're being requested for a hacking class.
That's my primary objective also. Like I wanted to show this Stack and Heap overflow, but I was going through it and it really took me really long time. And it's also difficult to explain sometimes, and let's see, maybe one time we can just do this 30-minute session.
Yeah.
Okay.
Yeah, we have done.
Like towards the ethical hacking session, not directly hacking or something. So.
Hey,
Yes, of course. Ankit.
I have a question. Do you have some open source tools which we could use in the application to see the security vulnerabilities, which can list the security vulnerabilities?
We have, I mean, it's not an open source tool. That's because we have internally a tool that passed through the source code all of the repositories, and it could look for the simplistic view of how this could potentially cause some sort of memory corruption or some overflow, and could go to the this CWE database and look up and could potentially cause us create us like a bug, which we could then analyze and then close it if it's not if it's really not a bug. So, but I don't know any open source tool, unfortunately.
So you guys get some license and run it in the
no, it's developed by our security team.
Oh, okay. So it's not like a static analysis tool. It's more like a static analysis tool than that.
It is, but it is like more customized in security aspects, and it has this CW database to look up for this kind of potential exploits and look for such things in the code.
Okay.
Mahavir and Honey, I don't know if you want to respond to that. I see you have posted some link.
Yeah, you asked about a security tool. We are using this flaw finder in some of our code bases.
Yeah,
I think it's it is open source, I guess. Yeah, but
and it's also using CWE database, I guess, right? It's officially has. Yeah.
I'm not sure of further details on it. I know this is being integrated in our GitLab CS scripts, so it will automatically run, and so
Yeah.
I haven't explored it much, but this could be a first try anyway.
Yeah, definitely. I mean, it doesn't make sense if it doesn't look up the CW database for such exploits.
Yeah, that makes sense. Okay, shall I ask my questions? And first of all, I want to know till what time? What time is our limit? Till 7? Oh, sorry, this is my time.
The limit is
No, I have 5. I have 5 questions, but I don't.
Yeah, my daughter is already with me here, so go ahead. She's still playing. It's not a problem.
Okay. And I will ask in my priority order. Which phase in
I guess you stop the screen sharing. Maybe you could try switching on the camera if that's okay.
For sure. If you guys want to see my daughter too.
Oh yeah. No problem. Sorry.
No, I think I stopped sharing, I guess, right? Okay. Yeah. Yeah. That's my daughter here.
So my first question is, which phase in SDLC this threat modeling is done? Does FMEA, FTA complement this threat modeling analysis, or are they mutually exclusive?
For example, I can say only from our perspective, we do this threat modeling. We have this kind of SSAs, like subsystem architectures, like we have this whole system and we have subsystem architectures. And there's an overall architecture team, to which we have to propose our own component architectures through SSAs, and then they have to approve it. And one of the ways to get approval is, one of the requirement is that you have this kind of threat modeling along with that and identify. So you can say at the beginning, but it's agile, right? Like, so you improve your architecture, you change your subsystem architecture, and then you update your threat modeling, for example.
Okay.
Yeah.
Thanks. Are there any ISO standards associated with threat modeling? Maybe I should rephrase it. Maybe cybersecurity would be there. Cybersecurity there will be. Okay.
Yeah, because this is we do threat modeling, but I don't know. The security team might know what's the ISO standard to it.
Okay.
But I'm not aware of it. Sorry.
Okay, so maybe my next question would be obsolete then. What are the skills required if someone needs to switch from software development career to cybersecurity career?
Yeah, like you need to be like some sort of ethical hacker for sure. Like we have a person from Iran who does this as a profession when he was in Iran. So he was a cybersecurity expert. So you should be really aware of all of this type of exploits. You should have this instinct of identifying such exploits in their own architecture, right? Like, I mean, it cannot be like not just knowing the C++ standard is definitely is one of the requirements if you're language specific. But if you're going to be a general cybersecurity, you should definitely have this kind of instinct to identify such exploits and vulnerabilities. Of course, there are a lot of courses and experiences which you can gain, but but I think it's like all professions, right? Like it's also not for everyone, probably.
Yeah, definitely.
Maybe I can add here because Dheeraj could add some security things here, and maybe Mauli sir wants to add something.
Yeah, what is required is the psychology of the coders, and maybe if we do more of code reviews, we'll know what kind of mistakes people do and where they miss out something. I think that's how we learn what could be the mistake that developer could make, and then how to exploit it. That's
exactly. So.
And I would add some knowledge of the law as well, because that's what you want to bend and break, right? So there are laws which say what is sensitive information, how and where it is kept. There are some recommendations around those, and then you pinpointedly attack those points, maybe.
Exactly.
Yeah.
But sometimes it helps if you don't know the law, because if you're law, then you become conscious if you want to break it or not. But for sure.
Definitely an attitude to break something would definitely help. Correct. Okay. And shouldn't controlled access privileges or privilege access as root non-root users also command as security?
I didn't get the complete question. What do you mean?
I mean, controlled access privileges. For example, when you say that, when you say this Stack Overflow and inserting shell code inside that, these access privileges, controlled access privileges should help there, correct? I mean, like.
If you're talking about the control access privilege in Linux, like this kind of ACL security layers, this would more talk about the external set of, for example, you have a component that's running and the ACL, this like kind of controlled access list, right? Like it restricts how this component can interact with others, how you can protect this component from, talking to another system. Like you, for example, I was talking to Ankur also about this, like you have a dbus as an inter-process communication between this, then you have like this kind of ACL system, how it could restrict this communication between the systems. But I'm not aware of any kind of such control access for the memory itself.
No, for example, if you are telling that exploiting the stack and inserting a script that could be run to break the system, if the privilege is set like no external scripts could be run, or like nobody has that execute permission, that itself prevents that attack, correct?
True, but in the stack frame, how can you set this to not to execute? Right, like you can make some of them read only so that it doesn't have write over it. You can set some sort of control through that mechanisms, but not on stack frames, or even in the heap. It's also dynamically allocated, so I think it's also hard to do that there.
I'm not fully aware of, but I guess there is something.
Sorry to interrupt. So what I understood basically here is when you insert some shell code inside a running program already, right, that program will now run under the privileges of what you started, right? So let's say there is an application which is started with the root privileges always, because it needs to connect with the sockets and everything. Now you put your code such a way in some memory location, and the return address, you corrupt that return address so that when the jump will happen, return will happen, it will read the address, This is how CPU architecture work. It will read that address and it will directly jump to the code. And if it will jump to the code, the privileges is as it is, right? The privilege is
Exactly.
not lowered down. So you have the complete privilege of a system.
Yeah.
So I guess the main thing is like at the CPU level, it does not know that these are two different programs. For the CPU, it's the same thing. So when you corrupt the memory address, CPU will be like, yeah, I just have to jump to this location. CPU does not know these are two different programs.
It's just a set of instructions, right, at the end.
Yeah, it's just zeros and ones.
But there
I
are
got
some
it. I was
ways that you can make
yeah.
some part of the memory read-only so that you don't corrupt them or rewrite on top of that. But yeah, there are such mechanisms. That's why you see the Stack Overflow attacks have reduced by some of these compiler features.
Non-executable stack is also one of these things that you can make the stack non-executable. So even if you overwrite a
Exactly.
buffer on the stack, then it won't execute the instructions.
Yeah.
Yeah, I haven't read it much earlier, but I know something like this thing, like some flag would be set, something like we
Exactly.
can make it
Yeah.
make it non-executable, something like that. Yeah, I have to read more on that. Okay, and my last question, which would be a potential discussion question about this exception handling. I know that modern C++ enthusiasts, they recommend usage of exception handling. But it is still a gray area whether we need to use in safety critical systems or not. And I know that this even popular coding standards prohibit the usage of exception handling. Would like to know your thoughts on that, and are exception handling being used in your projects?
Definitely, we are using both exception handling and error codes. For example, like when I said like schema validation, right? Like we have like a lot of JSON schemas that we use to communicate with the external through, and we do this validation of whether the JSON itself is still intact. And then if it's not, then we throw it and caught it locally, and then start this program, or we control the flow of the program. So we do definitely use exceptions, and also use error codes in some cases, like I mentioned, like this kind of program boundaries when you're communicating with another program in that case, or using a library, or we provide it as a library or application. In that case, we most probably use error codes. So we use both, and it depends on how you create your architecture, right? Like a strict prohibition, will never work, like you might know. So
years back, I work in a you mentioned MISRA SEEK standard, correct? So years back, I work in a project where we are prohibited to use dynamic memory allocation, exception handling as well in a safety critical system. So that's the reason I asked, like how people are using that exception handling.
Yeah, we also have MISRA C++ standards. We have a tool chain which runs against it and finds these bugs. But like I think I mentioned once, like we kind of ignore some of them because it's unlikely we can overcome that. And exception handling is one of these cases because we want to handle such exceptions. We want to control the flow of the program, right? So.
Okay, thank you on that. And I would like to know the audience opinion as well, Ankur or anyone. Like how are you managing are you using exception handling in your projects? Anybody, like, just to know about the thoughts.
In so many places in our code bases, exceptions are not commonly used. That doesn't mean I would recommend that. When I had a chance, I actually used exceptions, and even used across concurrency boundaries. So exception would happen on a different thread, and I'm posting a job on a different thread pool, and still I'm using exceptions to go through. So I would say, and I'm in a telecom time critical, latency critical area usually. So there again, the very fact that the exception is just a cost that you have for that a good way of error handling. It's not like lives will be lost, or it's not that part where it's deciding a lot which is at stake. So Exceptions are a very good way and a foolproof way of not missing on anything. Like if error codes, you don't check them.
Exactly.
You missed it. You missed it. You didn't even know that you had a problem, and you will have the 4th or 9th side effect of that issue half an hour from now. So that'll be too bad, not debuggable. So that's why I would actually insist on exception unless you have a very big reason not to use them.
Okay. Anyone else?
I just want to add on that.
You know my opinion very publicly. Use exceptions for irrevocable errors. Like if there is something, if your precondition is not valid, throw an exception. Because the way I program, and this is because I have not worked in teams, I work for myself as a student. So if my basic precondition is not satisfied, then it's out. I throw an exception and I don't catch it anywhere. So I just in main I just catch all exceptions, log them, and exit. So that for me as a student, the correctness of my program is of utmost importance. So once I have a precondition that has failed, it's out. There are no lives. Like in a car, if the program crashes, people's lives is at stake. In my program, so
you don't have a luxury of just logging and saying, okay, your one of your modules crashed and forget about it. We'll restart the car or something.
In fact, this is one thing which exceptions really are good at. Like, you don't have to do something about it where you found that there is a problem.
You can
because you don't even have the information about what you can do. You don't know who's invoking you at what place, how critical it is. And the same common functionality may detect an issue. And because of an invocation from a different place, it's very critical, and from a different place, it's normal. You can just eat that exception out and just log it and go ahead or something.
I would
say opening a file. Then I would prefer a variant which either gives me the contents of the file or gives me an error code, and I have to remember to check it. But I like the Rust approach. Rust has a result type which is essentially a variant of success and failure. But you need to check, like if to access that type, you need to. It's like visit. You need to check the type to access the contents. So you can never not forget. You can never accidentally access the wrong thing if an error happens. And Rust does not have exceptions, but it has a question mark operator. So once you get that result type, you can be like question mark, and if an error happens, it will return the error to the column, just like exceptions normally would. Otherwise, it will give you the contents of the success type. So it essentially emulates exceptions. Like if you don't exception, you can repeat the error of the stack. And otherwise, you can just continue moving on, like accessing the contents of the success. And it is such that because it is compile time, you can never forget to, like, you can never access the success value unless you want to check it.
Yeah, it's kind of language comparisons are always interesting. This kind of, especially features comparison. If you want to bring in such changes to C++ standard, it might take another 15 years.
It's, actually, I guess C++ is complex enough that we should leave it as it is. It's a library feature that library can implement in C++. And
exactly. So we already have some mechanisms. You do have your variant if you
the
choose
difference
to do it.
is just that it is not compatible.
You have optional,
yeah,
and I guess you have expected, which is come through or not, maybe not.
Yeah, I guess it's not there in the standard. It's available as a
No, not the expect. It is the STD expected.
Oh, okay. I would like why I ask this question here is like we had an interesting debate when we start our project whether we need to use exception handling and or not. I was one of the non-supporters of exception handling, and I heard all this. But if you see the main thing which one of the supporters of exception handling told is like code looks neater. Yeah, we removed a lot of junk code from our code base after implementing exceptions because 80% of the code is error handling inside a function. So when the exception comes, most of this will go to the handler and just throw. Yeah. Somebody else need to sorry to cut you off. Somebody else, CPP admin.
Yeah.
Yeah, I was telling about that. I also don't work on the safety critical things, but for us, performance matters. So I work on the CPU modeling side. So there also we use exceptions for scenarios. For example, as Hemil pointed out, that the errors are irrevocable. So we have something like, okay, now we are modeling some instructions there, and we know that, okay, this particular instruction, when it gets decoded, these operands kind of thing gets access in this fashion, and if it is not getting in that access in that fashion, we know, okay, there is some error somewhere, and we don't want to proceed with whatever the benchmark it is running. We just throw an exception, log the complete result there, and say, okay, we can't proceed further. So at such scenarios we use exceptions. So it's common to use both exceptions and errors, but you have to, really think what to use. Not overusing of exception, like, okay, you see in like, okay, this is an error condition, use exception. It's not good idea. Or
Yeah.
not to be too restrictive that, okay, don't use exception and just go with the error codes. So you need to have some balance.
Yeah, I mean, it comes down to your software architecture, how you want to, control the communication or the function flow itself. So
I guess
Yeah,
the
yeah.
important thing is having consistency versus choosing one over the other.
exactly, yeah, that's important, especially related to
Exactly.
exception.
That's what